So first of all, what is Docker? So Docker is an open source project that automates the deployment of applications inside software containers by providing an additional layer of abstraction and automation of operating system level virtualization on Linux. So that is the definition which is available on Wikipedia. But really, what is Docker? So Docker provides a uniformed wrapper around a software package, and this wrapper is called Docker container, which you can ship or build, and inside these containers you can run any app anywhere. Now Docker containers are similar to shipping containers. Now as you all know, in the shipping container, the container size is always same regardless of the content inside the container. So these container can fit on all trucks or ships or trains regardless of the content inside the container. In the same way, Docker packages a software into standardized unit for development, shipment, and deployment. So let me give you a real world example. So let's say I developed a Node.js application which depends upon some version of Node.js, and it uses some database and it's dependent on some shared library, let's say. And I want to give this software to the DevOps guy, or let's say to my colleague, to run it on his computer or on the QA system or on the cloud by DevOps or in the production system. So I don't really care where it runs. I just care that it should run when somebody tries to run my software. Now, if Docker is not present or any containerized system is not present, the normal procedure will be that I give my software to my colleague or the DevOps guys, and he has to install all the dependencies and, for example, Node.js version and the database system, exactly like a system on which I have tested my software. Now, if you will just use Docker to containerize your system, you just need to package your system into a Docker container, and you can just give this Docker container to your colleague or the DevOps guys, and he will just run this Docker container on the cloud or a QA machine or any other production system wherever he wants to run it. And he can just run your software without worrying about all the dependencies or the environment setup which your software depends upon. So nowadays, Docker is becoming more or less a standard for the containerizing systems, and you can find Docker containers everywhere on Linux operating system or Windows operating system, or in the data center, clouds, serverless application, and so on. Now let's compare Docker container versus virtual machines. So containers and virtual machine have similar resource isolation and allocation benefits, but Docker containers and virtual machine functions differently because containers virtualize the operating system instead of hardware, and containers are more portable and efficient. So when you talk about virtual machines, you can see this diagram on the right hand side. So virtual machines or VMs are an abstraction of physical hardware, turning one server into many servers, and it is made possible by the hypervisor, which allows virtual machines to run on a single machine. So each virtual machine or VM includes full copy of operating system. So let's say this is your server, and on this server you have your hypervisor, and on top of your hypervisor you can run different virtual machines. So this is virtual machine 1, virtual machine 2, virtual machine 3, which have this operating system 1, operating system 2, and operating system 3, or you can have the similar operating system in all the 3 virtual machines, let's say. Now the important thing to note here is each virtual machine includes full copy of operating system, the application necessary binaries, and the libraries, which takes up to tens of GBs of memory, and that is the reason that virtual machines can be slower. Now on the other hand, in the container, and you can see on the left hand side this diagram, so containers are an abstraction on the app layer that packages the code and dependencies together. So you have your server, and then you have your host operating system, and then on top of your host operating system you can run your Docker engine, and the containers are the abstraction at the app layer that packages the code and dependencies together. So multiple containers can run on the same machine and share the same OS kernel with other containers, but each container runs as isolated process in the user space. As a result, container takes less space than virtual machine, and usually container images typically takes tens of megabytes in size in comparison to the virtual machine, which can take up to let's say several GBs of memory. Also, containers can handle more application and require fewer virtual machines and operating system. Now when we talk about Docker containers versus virtual machines, the idea is to use containers and virtual machines together. So the containers and the virtual machines can be used together, which provides a great deal of flexibility in deploying and managing your apps. Now let's talk about the Docker architecture. So whenever you will install Docker, the Docker engine will be installed on your system. So Docker engine will contain Docker CLI, Docker daemon, and the Docker registry. Now there is something called DockerHub, which is a cloud-based service where you can share your applications, automate the workflow, and assemble apps for the components. Now when you talk about Docker, 2 things are really important, and these are Docker images and Docker containers. So first of all, what is Docker container? So a container is a standard unit of software that packages up your code and its all dependencies, so the application runs quickly and reliably from one environment to the other environment. Now when you create your Docker container, which is essentially a unit of your software, it can run everywhere regardless of the kernel version, regardless of the host distro. The only condition is that the container and the host architecture must match, and you can run anything inside your containerized solution. So if it can run on your host, then it can run on your container. That is, if it runs on a Linux kernel, it can run. Now let's talk about Docker container images. So a Docker container image is a lightweight standalone executable package of software that includes everything needed to run the application. That is code, your runtime, your system tools, and the system libraries and the settings. So the container images becomes container at runtime, and in case of Docker containers, images becomes containers when they run on Docker engine. So images turns into container when these images runs on your Docker engine. Now it's important to note that your Docker image is not a virtual hard disk or VHD. It's not a file system. It uses Union file system, and it's only a read-only layer. Also, the Docker images doesn't have any state. So when your Docker images runs as Docker container inside the Docker engine, and when you stop these running containers, these images will not have or will not save any state. So they are stateless. So basically an image is a tar file which has a hierarchy and an arbitrary depth. And that's how it fits into your Docker registry, for example, DockerHub or any private Docker registry. So this was a brief introduction about Docker. In this video, we are going to see how we can download and install Docker on our Windows 10 operating system. So let's get started. First of all, open your favorite browser and search for Docker. But before installing Docker desktop application on our Windows operating system, let's see what are the system requirements for installing this application. So before going to the dockerdoc.com website, I'm going to search on my browser install Docker Windows, which will open this link from docs.docker.com/docker for Windows. And this link I'm going to put in the description of the video also, so you can also see all the description here. And from here you can click this button, which is going to redirect you to the downloads page. But before that, let's see what are the system requirements for downloading this application. So as you can see here, for installing Docker on your Windows operating system, you need to have at least Windows 10 64-bit Pro, Enterprise or Education version, and Hyper-V and Containers Windows feature must be enabled. And some other requirements are 64-bit processor with second level address translation, 4 GB system RAM, and BIOS level hardware virtualization system must be enabled in BIOS setting. So if you don't have Windows 10 64-bit Pro version or Enterprise or Education version, then also you can install Docker on your Windows operating system, but the procedure will be little different. So for that, you can go to suspended products and tools, and then go to this tool which is called Docker Toolbox, which is now a legacy for legacy operating systems. So here you can just click on the install toolbox on Windows button. I'm going to just open this link in the next tab, and here you can follow the procedure of installing Docker Toolbox on your other Windows operating system. For example, if you have Windows 10 Home version, or if you have Windows 8 or Windows 7, then you can install Docker Toolbox. So first of all, how to check which Windows 10 version you have if you have Windows 10 operating system running. So for that, what you can do is you can just right click on this Windows button and then click on Run, and then just type winver, WINVER, and then click OK, which is going to open this kind of window. And here you can find the Windows 10 version you are running. So as you can see here, I'm running Windows 10 Pro version. Also, the second requirement was, so let's see the second requirement, which is Hyper-V and Containers Windows features must be enabled. So how to verify that? So to check that, the simple procedure is just right click on your toolbar, Windows toolbar, and then click on Task Manager. So once this Task Manager opens, you just need to go to the Performance section, and then you need to verify this section which is called Virtualization. It needs to be enabled. By default, it is enabled on your Windows 10 operating system, so you don't need to do any extra thing unless you have manually disabled this feature. So now I'm going to click this button which says download from DockerHub, and here you will see this web page first. So first of all, you need to create a Docker ID. If you haven't already have a Docker ID, you can just click on this sign up link here, which will open this kind of web page. And here you can create your Docker account, which requires a Docker ID, email address, and password. And you need to just agree these terms and conditions. So once you have your Docker ID, which I already have, I'm going to sign into my Docker account, which is going to redirect me to this page, which is the downloads page. And from here, I can just download this Docker desktop application for Windows. Also, if you have searched for Docker and if you have opened this main website from Docker, which is docker.com, you can just click on Get Started and then click on Download Desktop for Mac and Windows, which will also redirect you to the same page. And you can see, welcome, my Docker ID is shown here. So in order to download this desktop application, you need to have your Docker ID and you need to log in to the Docker website in order to download this executable file. So let's just click on this button, which is going to start the download of this executable file. I have already downloaded this executable file, so I'm going to cancel this installation. And you can see on my downloads folder, I already have this Docker desktop installer, which is around 856 megabytes. So I'm going to just double click on this executable file and I'm going to just start the installation. So I'm going to minimize this browser. And you can see the installation has been started. So the first window here is the configuration. So I'm going to just leave everything as default and then click OK, which is going to unpack all the files. The installation procedure is straightforward, I guess. You just need to click some buttons and Docker will be installed out of the box. And now you can see, after a few seconds, I can see this Docker desktop icon on my desktop, and you can see this message which says installation succeeded. So I'm going to just click close and log out button, which will log me out of Windows 10 operating system. So I need to log in once again. So now I have logged into my Windows 10 operating system once again, and immediately after logging into my Windows 10 operating system, I can see this window which says Hyper-V and container features are not enabled. Do you want to enable them for Docker to be able to work properly? I will say OK, which is going to enable all these features. I thought they are already enabled somehow, but according to Docker, it wants to enable them once again, let's say. And now I will click on this Docker desktop icon from here, which is going to start the Docker desktop application. And I can see this message, which is Hyper-V service VMM is not available. If you have enabled Hyper-V, just restart your computer now. So I'm going to restart my computer and I will then try to just start Docker application once again. So now I'm going to click on this Docker icon once again, and you will see on your toolbar here, you can see Docker is starting. So it will take some time to start Docker. And I can see this message which says Docker desktop is running. So I can open PowerShell and start hacking with Docker or Docker Compose. Also, when you click on this Docker icon here, you can see a bunch of options here for the documentation, DockerHub, switch to Windows containers, and all other settings here. So one thing I will recommend here is to sign in with your Docker credentials, which you have already created. And I'm going to sign in with my Docker credentials. And after signing in, you will be able to see your Docker ID and the sign out option. So let's get started with Docker. So first of all, you can start the command prompt. I'm going to just type cmd, which is going to show me this option, which is command prompt. and here you can just type docker hyphen version, or hyphen v will also work, and you can see the version which we have installed. Now let's also check if Docker is working with the Docker Hub perfectly fine or not. To test this, you can just run docker run hello hyphen world. Okay, so just run this command. This is the most popular command to test whether Docker is running or not, or it's able to fetch all the images from Docker Hub or not. So I'm going to just run this command, and when I run this command, you can see this kind of output. So you can see on the first line it says unable to find image hello world latest locally. So it didn't find this image locally, so it has pulled this image from the Docker Hub repository. So you can see in the next line, latest pulling from library hello world, and once the pull is complete, and you can see the status downloaded the new image hello world and then the latest version of hello world, and then it says hello from Docker. That means everything is working fine with your Docker and it's able to run your Docker images. And this is the first Docker image we have run, which ran successfully. Few more commands I can show you here. For example, you can also say Docker images and then press enter, and you will see the list of all the images you have on your system. So we have just downloaded this Docker image, which is hello world image. So this is how you can download and install Docker on your Windows 10 operating system. In this video, we are going to see how we can download and install Docker on our Mac operating system. So let's get started. So first of all, open your favorite browser and search for Docker. And the first link which will appear here will be from docker.com. So we are going to click into this link. And then straight away you can see this button get started or this button get started. So you can click on one of these buttons and then you will be able to see this button which says download Docker for Mac and Windows. So I'm going to just click on this button, which will redirect me to the Docker Hub website. Now in order to download the Docker binary, you need to have a Docker account. So if you haven't created a Docker account, you can just click on this sign up link here and then just fill your basic details like Docker ID, email and password and create your Docker ID and Docker account. And once you have your Docker ID and Docker account, you can just log in with your Docker account here on this website. So I'm going to just give my Docker credentials. First is the Docker ID and then second is the password. And now I'm going to just sign into this Docker Hub website, which will allow me to download this Docker desktop for Mac. So I'm going to just click on this download link here, which will start the download of the Docker. Now once this docker.dmg file is downloaded, I'm going to just click on this docker.dmg file and I'm going to minimize the browser. And you can see this DMG file is opening first of all. And once this window opens, you just need to drag this Docker icon to your applications. So it's that simple to install Docker on your Mac operating system. So once Docker is copied into your applications folder, you can close this window and open Docker from here, or you can just go to the launchpad and you will be able to see this Docker icon here. So you can just click on the Docker icon, which is going to start the Docker on your Mac operating system. So just wait for a few seconds. And now you will see this message which says Docker is an app downloaded from internet. Are you sure you want to open it? So I'm going to just say open. And in the next step, I can see this window which asks me to give some privileged access So I'm going to just click on OK, and then I'm going to give my Mac's password. And now you can see Docker desktop is starting on my Mac operating system, and you can see this Docker icon on top of your Mac desktop. So I will wait for this Docker desktop to start, and once this Docker desktop starts, we will start testing if everything is working fine. In the meantime, I can also give my Docker ID and password to log into the Docker using this Docker desktop application. So let me give my Docker ID and the password, and then I'm going to just say login, and you can see I am logged in with my Docker ID into this Docker desktop application. And now I can see this message which says Docker desktop is now up and running. So what we are going to do next is we are going to just open the terminal. So I'm going to just search for terminal, and then I'm going to open the terminal. And once my terminal is open, I can just check the Docker version by just giving this Docker version command and then press enter, and I can see this long message, and here the version information is displayed, and then the API version is displayed, and all the other information about my Docker is displayed here. Also, when I give docker info command, so let me just clear this terminal once again, and then I'm going to just give docker info command, and it's going to give me bunch of information about Docker and Docker engine and the status of Docker engine. Let me clear this terminal once again, and now I'm going to test Docker by giving this command. So I'm going to just say docker run hello world and then press enter, which is going to fetch this hello world image from DockerHub if it's not already present on my Mac locally. And once this image is pulled, it's going to just display hello from Docker. That means everything is working fine and you can start working with Docker. Now one more command you can use here is this command, which is docker images, which is going to show you the list of images which are present on your Mac operating system. And you can see I only have one image right now, which is hello world, which I have fetched just a few seconds ago. And you can see this Docker icon here. So when you click on this Docker icon, you can do lots of things. For example, if you want to restart your Docker, then you can just click on this. If you want to quit the Docker desktop, then you can click here. And there are lots of settings and updates and preferences settings you can do from this Docker desktop icon. And there are lots of other settings you can do from this window or this menu from here. So this is how you can download and install Docker on your Mac operating system. In this video, we are going to see how we can download and install Docker on our Ubuntu operating system. So let's get started. So what I'm going to do is I'm going to open my favorite browser, and then I'm going to search here Docker install Ubuntu. And the first link which will appear here will be from docs.docker.com. I'm going to put the link in the description also. So I'm going to click this link, which is the official documentation of installing Docker Engine Community Edition on your Ubuntu operating system. So here you can see the prerequisite of installing Docker on your Ubuntu operating system. So you can see the OS requirements, and right now I have this version, which is 18.04 LTS version. And if you have the older version of Docker or Docker IO or Docker Engine installed, you can use this command to uninstall previous versions of Docker. Now to install Docker, you can just scroll a little bit down and they have the very good documentation of installing Docker on your Ubuntu operating system. So we are going to just copy these commands and paste it on our terminal and we'll be good to go. So the first command is sudo apt-get update. So I'm going to just copy this command and I'm going to just open my terminal here and then just paste this command and then give my Ubuntu's password and then just press enter, which is going to update all the repositories. And then I'm going to just copy the second command in a meanwhile. So this is the second command, and in the second command we install the packages to allow the apt to use the repository over HTTPS. So let's just copy this command and go to our terminal, and then let me just clear the terminal. And now I'm going to just paste this command and then press enter, which is going to start the installation. I'm going to press Y and then press enter. And in the meantime, we are going to copy the third command, which is to add Docker's official GPG key. So for that you need to have curl, and curl we are installing using this second command. So when the second command is finished, you will have curl on your system, and then we can just give the third command. So hopefully that is complete. So let's clear the terminal once again and then paste the third command, and it's okay. So we will move to the next command, which is to verify that you now have the key with the fingerprints. So I'm going to just copy this and then paste it here and verify this, and you will see the similar result which is also shown here when you give this command. So now we will move to the next command, which is to install the Docker repository. So for Ubuntu you need the first option here, which is x86-64. So I'm going to just copy this command once again and then go to the terminal, clear this terminal and then paste this command and then press enter, which is going to install the Docker repository. And then in the next step we are going to update the repositories once again before installing Docker. So here you can see the next command, which is to update the repositories again, and then we are going to just install the Docker. So after update we are going to install the latest version of Docker engine, which is the community version. So for that we just need to give this command, which is going to install Docker CE and Docker CE CLI and container.io. So I'm going to just copy this last command and then paste it to the terminal. So clear the terminal, just paste this command and then just wait for the installation to complete. So it's that easy to install Docker Community Edition on your Ubuntu operating system. And if you want to install a specific version of these packages, you can give these commands. So when you give this command apt cache medicine docker -ce, you will see a different version of Docker which are available for your Ubuntu operating system. So from here you just need to take the version and then replace this placeholder for the version string with the actual version of whatever tool you want to install. So for example, if you want to install the version of Docker CE, for example, we need the latest version of the Docker CE, then you can just copy this and then just replace this placeholder string by this string. Okay, same you can do for the Docker CE CLI. So once this command is finished, I'm going to once again clear the terminal, and we are going to run this command, which is sudo docker run hello world. in order to test whether everything is working fine or not. And here I'm going to just write sudo docker run hello -world and then press enter, and I'm going to give my Ubuntu's password, and you can see when you run this command it prints hello from Docker. So first of all, what happens is, because we are running this Docker command for the first time, it's going to find the Docker locally, and if it's not found, then it's going to pull your Docker image from the DockerHub and then execute this hello world image, which is going to print this kind of output. So if you see this kind of output, that means Docker is running on your system. And also you can check the Docker images now. So you can just give this command sudo docker, which is going to list out all the Docker images you have on your Ubuntu operating system. So that's how you can install Docker on your Ubuntu operating system. In this video, we will talk about how does Docker works, and we will see some commands related to Docker and Docker images. So as I have told you in the earlier videos also, you can build your Docker images that holds your applications using Docker files, and then you can create your Docker containers from those Docker images to run your applications, and then you can share your Docker images via DockerHub or via your private registry. Now if you want to see this Docker flow in the form of a diagram, you can see this diagram here. So you can create a Docker file, which we are going to see how we can create a Docker file in the later videos. So Dockerfile is a file from which you can build your applications into Docker images. So what happens is you pull some images which are already there on the DockerHub, and you use those images with your application, and you write all that code or that script inside your Docker file. So how will your application run inside a container? You write everything in a Docker file, and then you build your Docker file, which will create a Docker image. And when you run your Docker image, it will be converted to a Docker container. Now let's see some commands related to Docker. So the first command which I want to show you is the Docker search command. So you just write Docker search, and then you give your options. For example, whatever image you want to fetch from your DockerHub, you can just write that image name. For example, I just write Ubuntu here. So you can search all the images which are there related to Ubuntu on DockerHub using this command. So Docker search Ubuntu. So when you give Docker search Ubuntu, you will see this kind of result in the form of a table. And the first column here is the name. The second column here is the description. Third is the number of stars. And if the image have more number of stars, then it's more popular. Also, you have the column for official. So if you see OK under official for a particular image, so for example, this first image with the name Ubuntu is the official image on DockerHub. And you can also see some description here. So clearly this first image, which is an official image also, is the most popular image on DockerHub about Ubuntu. Now let's see some options which are related to Docker search. So I'm going to just write Docker search here, and then I can give the filter option which we use to filter our results. So I'm going to just write filter here, So let's say we want to filter our result on the basis of stars an image have on the Docker Hub. So I can just write stars here is equal to 3 and then the name of an image I'm searching for. So for example, I'm searching for Ubuntu here, so I will just write Ubuntu, and this example will display the images with the name Ubuntu and which have at least 3 stars. Now I'm going to just press enter. So you can see all the result of the images which have at least 3 stars. Now if you give here, let's say number of star is equal to 100, so it's going to search for all the images which have at least 100 stars. Now if you want to give more than one filter, you can add this filter option once again. So you can just write filter and then the next filter. So the first filter we have here is for the stars, and the second filter I have added here is for the official image. So I just want all the images which are official. So that's why I have just given this filter, which is official is equal to true, and then I'm going to just press enter, and I will only see the official images which are present on the Docker Hub and which have more than 100 stars. In a similar way, I can also search for automated image which are not official but which are there by some users which are there on Docker Hub, right? So it's going to show you all the images which are not official but automated. Now there is this option which is called no trunk also, which is going to show you the description without truncating this description. So right now you can see in the description, you see this description and these 3 dots. So that means this description have more content in the description. So I can just give this option which is no trunk, which is not going to truncate this description, and it's going to show you the full description here. So sometimes this option can get really messy if the description is really large. So just use it wisely. Now instead of this hyphen filter, you can also simply write -f for the filter option. So either you can just give the full filter option, or you can just give -f for the filter, and the result will be the same. Now the next command which I'm going to show you here is the Docker images. So I'm going to just write Docker images, and this command we use to list out all the local images you have on your host. So when you give this command Docker images, it's going to give you all the images which you have on your host, as I said. And right now I only have one image, which is hello world image, which we have pulled in the previous videos when I have shown you how to install Docker on your various operating system. So right now I only have one Docker image, which is hello world. Now there are some options which are related to Docker images. So we are going to see all those options one by one. So with this Docker images option, you can give the name of the image. Now let's say I give here the option Java. So you can list the images using the name or the tag. So when you give this Docker images Java command, it's going to search all the images related to Java, and you can see there is no image which is related to Java on my host machine. So let's pull the Java image from the Docker Hub. So I'm going to just write Docker here and then pull. So the pull command you can use to pull an image or a repository from Docker Hub or from your private repository. So I'm going to just pull the Java image from the Docker Hub. So you can see when you give this docker pull Java command, it's going to pull always the latest tagged image from the Docker Hub. And in the output also you can see using default tag. So the default tag is always the latest tag. That's why it's going to pull the latest Java image. So now you can see this Java image with the latest tag is downloaded on my host. So let me clear the terminal, and now I'm going to give the docker images command once again. So docker images, and now I have the Java image with the tag latest and the hello world image with the tag latest. So now I can use the docker images and then the name of the image also. So I can search based on the name of the image also. So I can just write docker images Java, which is going to just give me the images which are related to Java. I can also search with the image name and the tag. So let's say I want to search for the Java image which have the tag let's say 8, which is not present on my host. So it's going to give you the empty result without any image. If you give the tag which is present, so the latest tag is present on my host, so it's going to give you the Java image with the latest tag. So let me give the docker images command once again, and you can see by default in the result you will see the name of the repository or an image, then the tag of that image, and then the image ID. This ID is very useful when you have multiple image related to let's say Java. So you can use this image ID to remove that image or work with that image. So that's why this ID is important. Also you can see when this image is created and the size of the image. So the different images with different tag have different sizes. So sometimes you want the images with the less size, or sometimes you want the images which have the full feature. So in that case you can use different kind of image with different tag which suits your requirement for your application. In this video we will talk about basics of Dockerfile. So first of all, what is a Dockerfile? So Docker can build images automatically by reading the instructions from the Dockerfile. And a Dockerfile is a text document that contains all the commands a user could call on the command line to assemble an image. Now, as I have previously told you, you can use Dockerfile, and then once you write your instructions in the Dockerfile, you can build your Dockerfile to produce a Docker image. And when you run the Docker image, it's called the Docker container. So let's see how we can create a Dockerfile, and then we will see how we can build our Dockerfile to make an image. So right now I'm in my home directory. So here I'm going to create a directory called D1, let's say, and then I'm going to cd in this D1 directory. And right now it doesn't contain any files or folders. So let's create our Docker file in this D1 folder. So I'm going to just write touch and then Docker file. So by convention, we usually name our Docker file as Docker file with the capital D. And this Docker file doesn't contain any extension. So it's without any extension. So let's create this file. So now I have this Docker file in my D1 folder, right? So now I'm going to open this Docker file in any editor. You can use the editor of your choice, write from the Nano, Vim or any editor. I like to use the Visual Studio Code editor, so I'm going to use that. So I'm going to just write code, and then I'm going to just write dot, which is going to open the current directory in my Visual Studio Code. So here I have this Docker file, right? Now in Visual Studio Code there are many extensions you can install related to Docker. That's why I like to use this Visual Studio Code, and straight away when I open this Docker file in my Visual Studio Code, I can see this pop-up which says Docker extension is recommended for this file. So you can click on this install button, or you can just install this Docker extension from this extension option here also. So you can just search for Docker here, and then it will give you the most popular Docker extension, right? So just choose the most popular one from here, and I'm going to just install this Docker extension. And once this extension is installed, it's going to help you with your Docker files and Docker commands in general. Okay, so there are a bunch of keywords which you can use inside your Docker file, and each keyword means something. So we will start with the arg keyword. So this arg keyword we can use to provide any argument, as the name suggests, and I'm going to explain this arg in detail after the other keyword, which is from. So here what I'm going to do is I'm going to just write version here, and version equals, I'm going to give here is 20.04. So version here is the name of the argument, and 20.04 is the value of the argument. Now after this we are going to use another keyword, which is from. Now this from defines the base image used to start the build process. So there are many base images which you can find on the DockerHub, and we are going to use one such base image, which is Ubuntu. And then after colon you can choose which version of Ubuntu base image you want to have. So here as I have defined this arg is equal to 20.04, so we are going to fetch the Ubuntu 20.04 from the DockerHub as our base image. So how we can use this argument with this from keyword? You just need to use this dollar symbol, and then inside these curly brackets you just need to pass your argument. So my argument name is version, so I'm passing this argument here. This means that we want to fetch the Ubuntu 20.04 image from the DockerHub. Now this from instruction supports variables that are declared by any arg instruction that occurs before the first from. And an arg declared before the from keyword is outside of the build stage. So it can't be used in any instruction after from. So now once we have the image, we are going to use one more keyword, which is the run keyword. So this run is the central executing directive for the Docker file. So this run you can use to run commands using the Docker file. So for now I want to run inside this Ubuntu base image apt get update commands, and also I'm going to give the flag y for yes. And now let's move to the next command. So the next command I'm going to use here is the cmd command. So the cmd command can be used for executing a specific command within a container. So let's say I just want to run the bash inside the container. So I'm going to just use these square brackets, and with the double quotes I'm going to just write bash here. So this is a very basic Docker file. Now let's see how we can just use this Docker file to build some image. So I'm going to open the terminal inside my Visual Studio Code editor, and as I can see, I'm in my D1 directory which I have created, and here I have this Docker file, right? So now let's list out what are the Docker images we have on our system. So I'm going to just write a sudo docker images command to list out all the images, and now I want to run or build this Docker file and create an image. So right now we have hello world, and I want to create one more image using this Docker file. So to build a Docker file, you can give a command build. So just write sudo docker build and then dot. So when you run this docker build command, the current working directory is called the build context. And by default, the Docker file is assumed to be located in this directory. But you can also specify the directory path using a flag called -f that we will see a little bit later. But just give this command for now, which is sudo docker build space dot. So now you can see that when we run this docker build command, the build is run by the Docker daemon, not by your CLI. So the first thing a build process does is to send the entire context to the Docker daemon, and that we can see here, sending build context to the Docker daemon. Now in most cases, it's best to start with the empty directory, and then you start adding your Docker file in that directory. Now when you run this docker build command, you will also see that these layers are fetched from your base image from the DockerHub, and also you will be able to see which step is executed. So the step 1 out of 4 is this arg step, step 2 is the from step, and at this step it's going to pull the base image from the DockerHub, and you have some intermediate layers here which are created, and then we have used this run command, which in itself has created its own layer, and it has installed the updates using this updates command, and at last we have given this cmd command. So now let's give the docker images command once again. So I'm going to just give sudo docker images command, and now you're going to see this Ubuntu base image which is fetched from the DockerHub, and you have this image which doesn't have any name or tag because we haven't provided any name or tag to our Docker image, and this only have this image ID which you can see here also, which is successfully built this image ID. So using this image ID, you know that your image is created here. Now let's say you are in some other directory other than the directory in which your Docker file is there. So for building a Docker file from some different directory, you use the -f flag. So what you do here, you just use sudo docker build and then -f, and then you just give the path to your Docker file. So when you give this command, and then you need to provide the context also. So you need to create this context inside this current directory. So when you give this command, it's also going to give you the same result. So because we have effectively given the same command, so we don't need to modify our image. So once again, when you give the docker images command, it's going to show the same image because your image is not modified and you haven't changed your context, which is your current directory. Now, as you can see, we don't have any name and tag to our image. So if you want to provide the repository name and the tag for your image, what you can do is you can give this docker build command and then give the -t flag. So using this -t flag, you can specify the repository and the tag at which you want to save your image. So let's say I want to give the repository name as my_app, and the tag which I want to give here is, let's say, 1. So after the colon, you can provide the tag also here. So when you run this command, and don't forget to provide this context, which is dot, which is the current directory, and then press enter, it's going to just create the same image, and you will see here an extra step is shown here, which is tagged with myapp:1. So at this step also, you will observe that Docker is smart enough to know that you want to create the same image from the same Docker file, and you haven't changed your Docker file, so it's not going to change your image or create or recreate your image once again, because we haven't changed our Docker file, right? We have just give the repository name and the tag. So now when you give this command docker images, then you will see that the repository name is myapp and the tag associated with it is 1. So this is how you can give the repository name and the tag. Now if you will observe here, we have our base image also here, which is Ubuntu 20.04. So in future, if you create different Docker file and it requires the same Ubuntu Docker image and the same tag, which is 20.04, then your Docker build command will be smart enough to know that, and it's not going to pull this image from the DockerHub again, because you already have this image on your local PC. So as I said, we have fetched this Ubuntu image and the version for it is 20.04. Here in the version, if you don't know the version, you can always write the latest. So just write latest here, and it's going to just fetch the latest version of the base image you want to have. So let me just save this file with the latest version and then run the same command with -t myapp, and the tag will be the same and the context will be the same. And now you will see that it's going to fetch the latest version of Ubuntu here. And now when I give this docker images command, you will see the tag latest here instead of 20.04, which was this more specific version I wanted, right? So latest is the latest version which will be available on the DockerHub for this base image. So those are some of the basics of Docker files. We are going to learn about Docker files in the upcoming videos also. Till now we have learned the basics of Docker files and how we can create Docker images using Docker files. Now in this video we are going to learn about Docker containers. So as I have told you earlier, when you run an image, it's called a container. So in the last video we have created this Docker file and we have already built our Docker file to produce an image. So let's list out the Docker images which we have created in the last video. So just give the command docker images here, and this was the image which we have created. We have named our image as my app, and the tag which we have given to our image is 1 here. Now this is the image ID. So let's see how we can run this image to create a container. Now in order to list out all the running containers, you have the command which is called sudo docker ps, which is going to give you the list of all the running containers. So right now we don't have any running container. Now if you want to see the list of all the container including running or the exited containers, then you can give the command with the flag -a, and it's going to give you the list of all the containers you have on your system. So it's going to give you the list of all the running container as well as if they are exited, and if they are no more running, then also it's going to give you the list of all the containers. So you can see I have ran this hello world container 2 months ago, right? And right now the status of this container is exited. That means it's not running. So this is how you can see the list of all the containers. Now to run a container, what you need is a command called run. So you just write sudo docker run, and then you can give with this run command some options, for example, and then you give the name of the image. So it requires the image in order to run a container, and then you can give some commands. So you can give some commands with the docker run image, and also you can give some args here. Okay, so let me just write args, right? So this is the basic syntax of a docker run command. So let's say we want to run our docker image, which is my app, right? So let me just once again give this docker images command, and I want to run this image. So to run a container, you just need one thing, which is the docker image. So you can just write sudo docker run and then the image ID. So this is the image ID of this repository, which is my app. So let's say we want to run this image. So I'm going to just take the image ID of this image, and then I'm going to just press enter, and as soon as I press enter, it's going to run the container and exits immediately. So when I run this docker run image ID command, then it's going to run and it's going to exit immediately, right? So when you give this docker ps command, so let's list out all the running containers, right? So all the running containers, still you will see there is no running container. But when you give this command with -a flag, which means we want to see all the containers, then it's going to show you that it ran this container with this image. So we ran the container with this image, and this is the same image which we have used in this command, right? And it was exited about a minute ago, right? So it ran and it exited immediately. Now here, one more interesting thing to note here is when you run the container with the run command, Docker automatically generates a container name with a string of randomly selected numbers and letters. So if you are wondering what this name is, this is just a automatically generated name which is generated by Docker for you. Now, if you want to give a specific name to your Docker container, there is a flag for that. So we are going to run the docker run command for the same image, and this time what we are going to do is we are going to give some name to our container. So before the image ID, I'm going to just provide this name flag, and then I can give the name to my container. So the name I have given here is my Ubuntu container to my container, and let's give the same command with this flag. And once again, you don't see any output here on the terminal, but as I have told you, it has just ran the container and exited immediately. So when we give the docker ps -a command, once again, you will see this time that now our container name is my Ubuntu container, right? So this was the container which we ran earlier, and this time with the last docker run command, we have given the name to our container, and the image was this one. So image is unchanged, but we have created a new container with the name my Ubuntu container, right? And the command which we ran is the bash command, which is coming from this line of Dockerfile. Now, when you run your Docker containers, it's run in two modes. One is attached mode or in the foreground, and other is in the detached mode or in the background. And by default, Docker runs the container in the attached mode. That means it's attached to the terminal session where it displays the output and the message. So if this Docker file has some commands or some output related to this Docker file, then it's going to show you the output in the terminal when you run the container with the Docker run command. But because we don't have any output associated with the Docker file, it doesn't show any output, right? Now, if you want to run your Docker file in the detached mode, what you can do here is you can give the -d flag. That means you want to run your container in the detached mode. So just give -d, and then I'm going to give the same command here, and let's see what happens. And you can see it's going to give you this message which says error response from the daemon conflict. The container name this is already in use, right? So this container we have already defined, so you cannot create this container with the same name. So you need to give the different name here. So let's say I'm going to just give my Ubuntu container 2 now, okay? And then I have also given this -d command to run it in the detached mode. And now you will see that there is an output which is printed here, and this is the container ID of your container. Now, if you have observed here in the previous command where it has thrown this error, it has this long container ID. Now, when you give the docker ps-a command, you will see in the container ID some part of this container ID is shown. So for example, I can see here up to this part of the container ID is shown, but in the background the container ID is so much bigger, right? So now when I give the docker ps-a command once again, I can see one more container which is created, and the container ID, you can see it's going to show you the starting few values of the container here until I think until D. So using this ID also you can delete or work with your container, or you can take the full ID of the container and work with your container. Okay, so this ID will also work, or in the short form or the first few letters of the ID will also work, which is shown here. Now we have seen that how we can run our Docker container in the detached mode, and as I told you that by default Docker runs the container in the attached mode or in the foreground, right? Now let's see how we can run our container interactively. So Docker allows you to run the container in interactive mode. That means you can execute commands inside the container while it's still running. So let's see how we can run our Docker container interactively. So now what I'm going to do here is I'm going to just create a new container. Let's say it's container 3, my Ubuntu container _3, and I don't want to run it in detached mode. Instead, I want to run this container in the interactive mode. So here I can give -it flag, which means that we want to run our container in the interactive mode. and the image name is same, which we have created using this Dockerfile. So let's see what happens when I run this command like this. So when I run this command like this, you will see the bash shell which appears here, and this is what I was expecting. So now, as you can see here in this Dockerfile, when we have created this image, the last command which we wanted is this bash command, and it has just given us this bash command shell in the last, right? So this is how you can run your container in the interactive mode. Now when I open the new terminal, so let this terminal be like this, and let me open the new terminal. In the Visual Studio Code, you can open the new terminal by just clicking on this plus button, or you can open your default terminal on your operating system also. You can see I'm in the second terminal, and here I'm going to give this sudo docker ps command without -a. That means I want to see only the running Docker containers, and then I'm going to provide my password of my operating system. And this time you will observe that when I give this docker ps command, it's going to give me some output, because now the container which I have created, which is my Ubuntu container 3, is still running in the other terminal. As you can see, we have running bash shell in the Docker container. So this bash shell is running inside our container, right? So when you just give some ls command, you will see the file system directories here inside your container. You can also give, for example, uptime. So as the name suggests, the uptime command will give you the time for which the system has been up or running, right? And as we have seen in the last video, we have only given this bash command, so our container is not doing much. It's just opening the bash shell. Now there are many interesting things which you can do with your docker run command, and that we are going to see in the next videos also. I want to show you some more commands related to docker run and docker in general. So now what I'm going to do is I'm going to switch to my terminal. So I'm going to open my default terminal on my Ubuntu operating system. Also, I'm going to open my browser and I'm going to just search for DockerHub. I want to show you how this DockerHub looks like. So the first link here is hub.docker.com, and when you click on this link, you will see this web page here, from where you can just sign in with your Docker ID which you have created earlier, or you can search for some images. So let's say I'm going to search for an image called busy box, and then press enter, and you will see an official image of busy box. And as you can see, you will see the tag here on the top, which is going to show you if it's official. It's going to show you it's an official image, and otherwise it's going to show you verified or the other information associated with the image. So the most popular one and the official one is this one. So I'm going to just click on this base image, and here I will see some more information related to this image. So if I want to just pull this image on my PC, I can just give this docker pull busybox command. So let's do this, and I'm going to show you how we can use the docker run command with the busybox image which we are going to pull. So I'm going to just write docker pull busybox here, and then press enter, and I'm going to just give my Ubuntu's password, which is going to just pull the latest tag image of the busybox, right? So if you don't provide any tag after colon, then it's going to pull the latest image. So now let's run the docker images commands. So I'm going to just give images, and now you can see this busybox image is there. So you can run the docker run command with the images you have in this list also. So till now we have seen how we can run the docker run command with the container which we have created, but you can also use this docker run command with the base images also. For example, busybox or Ubuntu 20.04 or Ubuntu latest version. And I have pulled this busybox base image because it's very small in size. You can see it's only around 1.22 megabytes. So if you want to quickly test something with some Linux terminal or Linux operating system, busybox is the image to go. So now, as I told you, you can use this docker run command with the images you have in your local PC. So you can just give docker run and the name of your image, which is busybox here, and then you can do something with it. So you can just write echo. So it means that we want to run the echo command inside our busybox container when it runs. And let's say we just want to print hello world here. So I'm going to just write hello world and then press enter, and it's going to run this busybox image as the container, and it's going to print or execute whatever command you have given after this busybox command, right? So basically what this means is we are running echo inside our busybox container. Also, when you give the docker ps-a command, so let's give this docker ps-a, and you will see this busybox command also. So you can see this busybox and what command it has ran. So we ran echo hello world, and it was created 42 seconds ago and it was exited, right? So status is exited. Now let's say you just want to work with the busybox shell. What you can do, you can just give the same command, but instead of giving this echo, you can run it in the interactive manner using this IT flag, and then you can just tell that you want to run the shell. So just write sh, which is going to run this container and open the shell inside the container, right? So let's give this command, and when you give this run command with the IT flag, it attaches us to the interactive TTY in the container, right? So because we are running the sh command after this run command, so it's going to open the shell inside your busybox container. And here again you can run your basic commands or whatever you want to do inside the container. So we are not working inside our operating system, we are working inside our container. Now in order to exit from the container, you can just give this exit command and you will come out of this container. Now the last thing which I want to show you before just finishing this video, and that is how we can remove some containers. So now we ran so many commands and we have so many containers, and as you can see we have so many dead containers. That means all the containers are exited and they are not running anymore. So when you give this docker ps command, you can see only one container is running, and all the other containers when you see using -a are exited. So let's say you want to remove some of these containers. So let me clear the terminal and let me just give this docker ps-a command. So let's say I want to remove this container and this container. So there is a very simple command which is called rm. So you can just write sudo and then the docker command and then just give rm, and then after that you can give the container ID of the container. So let's say I want to just give this container ID of the container. So just copy and paste this container ID and then press enter, And if you see the container ID in return in the output, that means this container is removed. So once again, when you give the docker ps-a, you will see that this container is already removed, right? So in the same way, you can remove multiple containers using this rm command. So you can just give container id space container id 2 space. You can give multiple container id in this manner, and it's going to remove all the container IDs which you have given after the rm command. So right now we want to remove 2 containers, and as I said, if you see the container ID in the output, that means that container is removed. And in my case, as I can see, this container is removed, but the container with this ID is not removed. It means the container with this ID is not removed because it's running, right? So if the container is running and if you want to remove it, you need to stop this container first, and then you can remove the container. So as I have shown you, this container is running here. So I can either just give this exit command, or I can stop the container. Let's see how we can stop the container using a command called stop. So let's say I want to just stop this container. So I can just give the command docker stop. Just write docker stop and then the name of your container. So my container name is this one. So I want to stop this container and then press enter. And if you see the container ID in the output, that means this container is stopped. So when you give this docker ps without -a, you can see there is no container running anymore. And now in the list of all containers, you will see this container. And now when you give this docker rm with this container ID, it's going to give you the output. That means this container is successfully removed. Okay, so you use stop command to stop the container, and then you can use rm command to remove the container. In the last few videos, we have seen the fundamentals of using Docker files, Docker images, and Docker containers. Now in this video, I want to give you a concrete example of using the Docker container. So I'm going to give you a real world example of how you can really use Docker containers and how these Docker containers are really useful in certain situations. So we are going to compile and run a C++ program inside a Docker container. Now you might say that compiling and building a C++ program on your host operating system is also easy, so why do we need a container? So consider a situation in which you have a C++ program and you want to compile a C++ program with different version of GCC, let's say. Now it's really hard to maintain different version of GCC on your Linux or Windows operating system, but using Docker containers, it's really easy to use and compile your program in different GCC versions using Docker containers. Also, let's say you want to develop a C++ program which works on multiple operating system, or you want to compile your C++ program for a cross-platform application. So Docker containers are really useful for C++ cross-platform development with containers. With containers, you can choose a target with a platform that runs completely different operating system other than your host operating system or the system on which you are developing. So let's say you are just working on your Windows operating system, but you want to compile your C++ program on a Linux operating system or any special version of Linux operating system, you can do it easily with the Docker container. So let's start with our example. So as you can see on my Visual Studio Code, I have opened a Docker folder, and inside this Docker folder I have this directory D1 which we have created in the previous video. And now I'm going to create a new directory inside this Docker directory, and I'm going to name this directory as D2. And now I'm going to just go inside this D2 directory. So let's go inside this D2 directory, and here inside this D2 directory I'm going to create a new CPP file, let's say. So you can use touch on the terminal, or you can just click on new file here and then just create a new CPP file with the extension CPP. I'm going to name my file as main.cpp. And as soon as you create a CPP file inside your Visual Studio Code editor, it's going to give you the suggestion for the C++ extension. So I'm going to install this C++ extension. So now this C++ extension is installed, and this C++ extension is going to help me to work with the C++ file inside my Visual Studio Code editor. So what I'm going to do here is, inside my main.cpp file, I'm going to just write a very simple program here which just prints hello Docker container. So normally what you will do on your host machine, if you have a G++ or GCC, you can compile your C++ program using G++, right? So you can see I have this main.cpp, so I can compile this program using G++ -o and then the executable file name which I want to create. Let's say I want to just give the name test to my file, and then my main.cpp file, right? So I'm going to just press enter, which is going to create this executable file. You can see here also, I'm going to do ls here also, so you can see this executable file. And now you can just run this test executable file or binary file using this command // and the name of your binary file, and it's going to print hello Docker container. And I want to create a Docker container, and I want to compile my C++ program inside my Docker container, and I want to run my C++ program inside my Docker container. This is what I have done in my host machine, not inside my Docker container, right? So let me just clear the terminal, and inside my D2 directory where my C++ file is there, or my CPP file is there, I'm going to create a Docker file. So I'm going to just right click, and I'm going to just create this Docker file here, and then press enter. And I can remove this test binary file because I don't need it for my Docker container. Now if you don't know which base image you want to use, so for example, if you want to use GCC to compile your C++ program, you can go to DockerHub and search for GCC here, and when you search for GCC, you will be able to find the official GCC image here. You can see Docker official image, or let's just press enter and see what result it gives. So you can see the official image is this one with this official image tag, and it has more than 10 million downloads. So I'm going to just click on this GCC link, and you can see when you just scroll down what are the tags you can use with GCC. Also you can see how you can pull this GCC base image using Docker. So the name is really simple, GCC. So what we are going to do is we are going to just write from, and then our base image I'm going to use here is GCC. Now the version or the tag I want to use here is the latest, or you can choose the tags which are available here. So you can choose 10.2.0 or 10.2, or from all these tags which are available here. You can also go to tags section and see the more specific tags you want to use for your C++ program. So now once we have the base image, the next step is to copy our current folder which contains our CPP code into the Docker image under the file system where we want to copy this. So for copying our local files into the Docker image, we use this copy command. Okay, and as you can see, it suggests us that we need to provide the source. So source in our case is dot, because we want to copy all the files from the current folder, and the destination will be the destination inside the file system of your Docker image. In our case, it's GCC. So in GCC base image file system, you will find this path which already exists there. So you can just write user/src, which is already there inside the file system of GCC base image. Okay, so as I said, this command is going to copy all the files which are there in your local directory to this directory inside your Docker image. Okay, now if you want to copy some specific file, then you can do this also. You can just write main.cpp, and then you can copy a specific file into the folder which should already exist inside your image which you are using, right? So for now, for simplicity, I would just want to copy all the files from the current directory to user/source/ the directory which we are going to create. So let's say we want to create this directory where we want to copy all the files, cpp test, let's say. So this path already exists in the file system, and this is the folder name which we want to create and copy our local files to this folder in the Docker image, right? Now we are going to define the work directory. So we can just use this work dir keyword to define the working directory in which you want to work now. Okay, so because we want to work inside this directory, because we are copying our C++ file inside this directory, we are going to set our work directory as this one. That means when you run any command, it's going to run inside this directory which you set as work directory. Now in the next step, I want to run the command which will compile the C++ program using this main.cpp. So now I can just give the g++ command, then -o as the flag, and let's say I want to name my binary as test, and the file name which I want to compile is main.cpp. So this run command is going to compile my C++ program inside my cpp test directory under user source folder, right? Now in the next step, I'm going to give the command using cmd, which will be the command which I want to run inside the container. So this is going to run the program output from the previous step into our container. So this works like this, as you have already seen in the last video also. So if you want to run your binary, you can just give // and the name of your binary, which is test, right? So this binary is going to be run using this cmd command inside our container. So that's it. That's how you can create this Docker file to compile your C++ program and run it. Now let's build our Docker file to create an image. For that, you can just give sudo docker, then your build command. So build and then the build context, and then you can provide -t to provide the name of your image. I'm going to name my image as cpp_test, for example, and then you can also give the tag to your image. Let's say I want to provide the tag 1 to my image. Okay, so this is going to create a Docker image using the Docker file. So you can see it has pulled the base image in the first step, then copied our files from the local directory to the directory which we have defined, and then it has set the work directory, and then in the next step it has compiled our C++ program, and in the last step we have set the test binary to run when we run our container. So now let's list out all the images. You can just give docker images command for that, and you will see that this repository is created about a minute ago, and this is the image ID for that image, right? So now we want to run our container using this image. So for that, we have seen in the last video, we can give sudo docker run command, and then I'm going to give the --rm flag, and this rm flag causes Docker to remove automatically the container if it already exists. So if the container which we are going to run already exists, then it's going to remove that container, and then it's going to rerun that container. So this command is handy when you want to just run only one container at a time. And then I'm going to give this IT flag with hyphen, so IT flag for running this container in the interactive mode, and then your image. So you can give this image name cpp test here, or image ID also you can give. So I'm going to give the image name, which is cpp_test with the tag. So tag we have provided is 1. Okay. So here, as I said, you can give the image ID or the repository name and the tag. And then when you run this Docker container, it's going to print hello Docker container. That means we ran the test binary inside our Docker container, right? Now, as I said, you can change this tag. Instead of latest, you can choose the version of GCC you want to use for compiling and running your C++ programs. So that's why this Docker and Docker containers will help you to just cross-compile in cross-platform applications. Now let's say you want to compile your C++ program using the CLang compiler instead of GCC. Okay, so we want to compile our program using CLang compiler instead of GCC. So let me clear this terminal and let me go one directory up here, and I'm going to create a new directory. So I'm going to just write mkdir d3, and inside this d3 directory, what I want to do is I want to just have the same cpp file. So I will just copy this cpp file into the d3 directory also, and then we are going to create a Docker file inside this d3 directory. So let's create this Docker file here. So now let's move to the DockerHub website and let's search for CLang if we have something related to CLang compiler on DockerHub or not. So I'm going to just write CLang here. And as I remember, there is no official base image for CLang on the DockerHub. So what we can do, we can use the base images we already have on our system, and then we can install the CLang compiler on that base image. So I'm going to just give this sudo docker images command, and from these images, let's say we will use this Ubuntu latest or Ubuntu 20.04 to compile our C++ program inside the Ubuntu base image using the CLang compiler. Okay, so what I'm going to do is I'm going to just write this kind of Docker file. I'm going to explain you all the steps one by one. So we want the base image Ubuntu with the tag latest because we already have downloaded or pulled this image in the previous videos, so we don't need to pull it once again. Now in the next step, I'm running apt get y update and apt get install update to update apps on the base image. So that's what you do when you want to install any software on your Ubuntu operating system. So this command is going to update the apps on the base image. Now in the next step, using this apt get -y install CLang command, we want to install CLang on our base image, which is Ubuntu, right? The next step are relatively easier because we have seen these steps in the other Docker files also. So we want to copy all the files in the current directory into this directory inside our base image, and then we want to set the work dir, which is the same where we have copied our C++ files. And then to compile your C++ program using clang, you can just replace the GCC with clang++, and the rest of the command will look like same as you have seen in the case of GCC also. So you can see g++-o test main.cpp, and here also you can give this command. The only thing I want to change here is the main.cpp, the file name here. Okay, because our binary name is test, we are going to just run this binary using this command. So this is going to run inside our container. Okay, in the D3 folder, I have created this Dockerfile to compile my C++ program using clang, and I'm going to run this now. So let me clear the terminal once again. So now let's build our Docker image using this Dockerfile. So for that, I need to go inside the D3 directory, and then I'm going to give the Docker build command with the context in the current directory, and then -t to give the name of my image. So let's say I want to give the name to my image as clang_cpp, and the version or the tag which I want to provide here is, let's say, 1.0.0. Okay, so let's build our image using this command. So now, as you can see, the build of this image is successful with the name clang_cpp and the tag 1.0.0. So let's run the container for this image using the docker run command. So I'm going to just provide sudo docker run. Oops, by mistake I pressed Ctrl+C, that's why it braked. So let me just give this command once again, and then give this image name with the tag 1.0.0. So we want to run our container using this image. So let's press enter now, and as expected, we see hello Docker container. That means we successfully ran this binary file which is compiled using clang in our container, and the output is printed. Now let's say you want to change something in the output. So instead of let's say hello Docker container, I just want to print hello world here. Okay, so I will just save this program, and then I can just build it again, but this time I will build it with the different tag. So let's say I just did the minor change, so I will just change the tag as 1.0.1. So let's build this image, which is going to be built really fast. And now let's run this image using this docker run command, but don't forget to change the tag, because I have changed the tag for the image also to 1.0.1. So here also I'm going to change the tag for the image, and then press enter, which is going to run this program, and it prints hello world. So how simple is this? So this is how you can compile and run your C++ programs using Docker containers. So as I said, I just wanted to give you a real world example. Same thing you can do for your Java programs or any other programs which you want to run in different environments. In this video, we are going to see how we can do port mapping between your Docker container and your host machine. So let's say you have some kind of server, and that server listens on some particular port. So you need to expose your port from your Docker container, so the outer world will be able to interact with your server. So in this video, we are going to take an example of a Node.js server. The same concepts you can apply on any other kind of server. It can be a Nginx server, it can be a Python Flask or a Django server, or any other kind of server. So let's start with our example of Dockerizing our Node.js web app. So what I'm going to do is I'm going to just create a new directory for me. So I'm going to just write mkdir d4, and then I'm going to go inside that d4 directory, and here I'm going to create a new Node.js app. So for initializing my app, I'm going to just write npm init and then -y and then press enter, which is going to create a package.json file inside my d4 folder. Now for this Node.js server, I will be using Express. So I need to install Express locally for this app. So if you already know something about Node.js or npm, you can easily install the npm package using npm install and the package name. In our case, it's Express, which is a very popular Node.js package or npm package. So I'm going to just write Express here, and then I'm going to give this save flag here. So it's going to be installed inside my directory, and this Express will be added as the dependency in my package.json file. So let me press enter, which is going to install this Express package in my directory. You can see this new directory is created, which is node modules, and this new dependency is added in my package.json, which is Express. So now let's create our server.js file. So if you can see in our package.json file, the main entry point right now is the index.js. You can change it to server.js, and let's create this server.js file, server.js here, and then press enter, which is going to create this server.js file. So we are going to write a very simple Node.js code, which is going to use Express, and it's going to just print hello world whenever somebody will make a GET request to this server. So I'm going to just copying and pasting this code, because this code is available everywhere and it's very simple. So what I have done, I have just imported this Express, and then I have created these two variables. One is the port variable, which will be exposed via a browser or via the REST request, and then we have the host here, which is basically the local host, and we have one GET request here. So whenever somebody makes a GET request to the server, we are going to just send hello world. So very simple Node.js server code, and we are going to run this code. Let me clear this terminal. So I'm going to just write node and the name of my server file, which is server.js, and when I just run this server.js using Node.js, it's running like this, and it's printing on which host and ports it's running. So let's open our browser, and we are going to just open this URL, which is 0.0.0.0 colon the port number on which we have started this Node.js server, and I'm going to just press enter, and it just prints hello world, which is the expected result, right? So now we want to Dockerize our Node.js server. So let's see how we can Dockerize our Node.js server. So for that, I'm going to just close this app or stop this app, and now I'm going to create a new Docker file. So let's just create this Docker file by just giving this command, which is touch Dockerfile. Now I'm going to go inside my Docker file, and here inside my Docker file, I'm going to use the node base image. So when you go to the DockerHub, there is an official base image for Node.js, and that's what we are going to use. So I'm going to just write from, and the base image will be Node, and the version of Node we are going to use is version 12. So you can use the latest tag also here, which is going to give you the latest version. Now in the next step, I'm going to define the working directory using the work dir keyword, and we are going to define this work dir in the user /src/app folder, and now this should be work dir, right? So like this. Okay, so we have defined our working directory. Inside this working directory, we are going to copy our code, and then we are going to do all the stuff. Now let's copy all the files which are there in our current folder to this Docker image. So we are going to use the copy keyword to copy all the files. But first of all, we need to copy the package.json to the container so that we will be able to run the npm install command. And npm install command, what it does, it just installs all the dependencies into our container, right? So let's first of all copy the package.json file. So we are going to copy the package log.json file and package.json file. So these two files are responsible for all the dependencies to this directory, right? So now we have copied the package JSON files. So next step is to install all the dependencies using npm install. So you can just give this command, run npm install. Now if you are working in the production environment, this command can be a little bit different. Let me just write this in the form of comment. So you can just write run npm ci, and then you can give this only production flag, production. Okay, so if you are working in the production environment, you can give this command. If you are working in the development environment, then you can just do this command. So npm install will install all the dependencies, and in our case there is only one dependency, which is express, right? So via this npm install, this express npm package will be installed in our Docker image. Now in the next step, once all the dependencies will be installed, we are going to just copy all the files which are there in our server code. So we only have this one file, which is server.js, but let's say you have many modules and many files inside your Node.js projects. So I'm going to just write copy, and then I'm going to copy all the files and folders which are there in the current directory. Okay, now next step is important, and this step is we are going to expose our port. So I'm going to just write expose, and we are going to expose the port which we are using in our server. So we are using port 8080 in our server, so we are going to expose this port. That means that we want to expose port 8080 into our Docker container. So this expose keyword means that we want to expose port 8080 from our container to the outside world, for example to our host machine. And this expose is a way of documenting, so it's not going to publish your port at runtime. It's just a way of documenting in your Docker file that you intend to expose this port 8080 in your Docker container. So exposing port using this expose keyword is a way of documenting which port are used, but it does not actually map or open any port. We are going to open and map the port using the docker run command, and we are going to use a different flag for publishing our port or opening or mapping our port later when we just build and run our docker container. Now the next step here will be to run our Node.js application, and we all know that we just need cmd, and then inside our square brackets we will just write npm, and then we are going to just give this comma, and then we are going to give the name of our server.js file. So this will be server.js. Now here one interesting point to note here is when we are going to copy all the files and folders from our current directory to the Docker image, you can see I have used dot. That means it's going to copy node modules also into your Docker image, and we have already installed our node packages using this npm install. So this is going to overwrite this node modules folder from your image, right? So to avoid copying your node modules into your Docker image, you can create a docker ignore file. So this docker ignore file is going to prevent your local node modules or your debug logs from being copied into your Docker image. So let's just create this docker ignore file. So to create this docker ignore file, you can just write touch.docker ignore in the same format which I have used. So this format is recognized by Docker, and whatever you write inside this docker ignore file. So let's create this docker ignore file first of all. So we have created this docker ignore file, and we want to exclude the npm modules and npm debug.log file from copying into our image. So this means that we have added npm modules and the npm debug log file which will be excluded when we are going to copy the files from our local container to the Docker image. Okay, so this will avoid the overwriting of our npm modules. Now we are done and we can build our image. So let me clear this terminal. So now let's build our image by giving the docker build command. So I'm going to just write sudo docker build -t and then the image name. So let's say I'm going to just give the name node_test : the tag. You can give any tag to your image. So let's say I am going to give 1.0.0 tag to my image, and then the context, and then press enter, which is going to just build this image, and in few seconds this image will be created. So let me clear this terminal once again, and let's list out all the images. So sudo docker images, and when you see here our docker image is created with the tag 1.0.0 15 seconds ago. Okay, so now we are going to run our container. So to run our container, we can just use sudo docker run. So as I told you, we want to expose this port 8080 so that this server can listen to the request from the outside the container, right? So in order to map the port, we use the flag which is called -p, which is also called publish, and -p is a way of mapping a host port to a running container port. So this is our running container port, and let's say we want to map this port which is running inside the container to our local host machine. and we want to, let's say, give the port 3000 in our local host machine, and which is going to be mapped to port 8080. So if you specify this expose the port, and if you specify this publish flag to map the ports, then the service in the container is accessible from anywhere, even outside the Docker. So this means that we want to expose port 8080 from our container to the port 3000 inside our host machine. And now let's give the name of our image which we want to run, which is node underscore test colon 1.0.0. okay, and let's run this Docker container, and this gives me error, and the error is obvious because instead of using npm I should have used node, okay, because we have started our server using node command, not npm. Npm we use just for installing our packages and managing our packages, right? So let's rebuild our image once again, and once our image is rebuilt, we are going to just run our container. So now our container is running and we can see the same output. Now we might be confused, or you might be confused, that we are exposing the port 8080, and when we go on this URL on our browser, so let's go to this URL on our browser and let's see if it works or not. So it's not going to work because we have mapped the port 8080 to the port 3000 on our local machine. So this is the port on the container, on your Docker container, and this is the port which it will listen on your local machine. So we want to listen on port 3000 on our host machine. So instead of port 8080, you can give port 3000 and it's going to print hello world, right? So this is how this port mapping work. So this will be the port which will be available on your local host, and this is the port you have exposed inside your Docker container. So let me just stop this container. So I'm going to go to the next terminal, and I'm going to just write sudo docker ps to list out all the running containers, and this container is running. So I'm going to just use the container ID from here, just copy the container ID and then sudo and then the container ID which is going to stop this container. So now this container is stopped, and you can see in this terminal also that we are out of the container, right? So now let's say, let me just clear this terminal, and now let's say we want to map to the port 8080 itself on our host machine also from our Docker container. So this is the port on the Docker container, and we want to map this port to the same port on our host machine. If it's available, then it's going to run fine. So let's run this command, and now this time when you go to the browser on port 3000, obviously you will not get anything because we have mapped the port 8080 to our host machine now. And now when you give port 8080, it's going to give you hello world. If you want to run this server in the detached mode, as I have told you, you can use -d so that this Node.js will run in the detached mode. That means it will run in the background. So this is how you can expose the HTTP port. You can also expose the TCP port and the UDP port from your Docker container. So let me just stop this container. So I'm going to just stop this container first of all, and let me show you how you can expose the UDP and the TCP ports. So let's say you are running application, and in this application you are doing some TCP communication or the UDP communication. So for mapping the TCP port and the UDP port, you can use the flag -p, and then you can use this kind of notation. So the port which you want to expose from your container, let's say I'm just exposing port 80 and /TCP. So in case you want to expose the TCP port, you just need to write /TCP after the port which you want to expose from your container, and this will be the port you want to expose to the host machine. So this port will be available on your host machine from this port to your container. So this is the mapping, right? For UDP, you just write /UDP, right? So the flag is -p. You just need to write /TCP or /UDP to expose the UDP or the TCP flag. You can expose multiple ports also by using this -p flag. So it's not that you just can use only one -p flag. You can use multiple -p flags to expose multiple ports from your container to the host machine. So this is how port mapping works in Docker. I hope you have understood this concept. So in this video, we are going to talk about DockerHub. So what is DockerHub? So DockerHub is a service provided by Docker for finding and sharing your container images with your teams or with the general public. So as you can see, I'm on this website, which is hub.docker.com, and here I can sign in. At the time of downloading the Docker on your operating system, you might have created a Docker ID for you and the password for you, so you can log in with that Docker ID and password. So once you are signed in with your Docker ID and password, you will be able to see this kind of web page here. You have this explore option where you can explore all the other repositories. You have this repository option, and under this repository option you will be able to see and manage your repositories which you have created and which you have pushed into your Docker registry here. You also have the option for organization, which we are not going to cover in this video, and also you have all these general account related stuff here, right? Now let's talk about the pricing a little bit. So you can see for public repository, DockerHub is absolutely free, and that's what we are going to be using. But if you are working in an organization or you want to create some private repositories for your Docker images, then you can choose one of these options which are provided here. Also, it's not necessary that you need to use DockerHub as a Docker registry. You can create a Docker registry. You have this documentation which you can use to create a Docker registry. I know Google Cloud provide a Docker registry, or GitHub nowadays also provide these kind of Docker registries. So you can create your own registry if you want. You don't need DockerHub for just managing your images, right? So right now you can see I don't have any image on my DockerHub account. So to start with, I have this very simple Docker file which I want to convert to the Docker image, and then I want to push that image to my DockerHub registry. So let me list all the Docker images on my operating system. Right now I don't have any image, so let's build one image. So I'm going to just write sudo docker build -t and the name of the image. I'm going to just name my image as hello, and then press enter, which is going to just create this image. I have this hello world image which is created 5 seconds ago, right? So now let me just also quickly run this image to see everything is working. So I'm going to once again write sudo docker run -rm -it and the name of the image, which is hello, and then press enter, and it prints the content of my main.cpp. That's what it's doing. So that's a very basic minimal image. The size is very small, that's why I have done this. And once you have all these images, let me just clear the terminal, and then let me just move this terminal a little bit up, and let's just list all the images once again. So now I have this image hello, and I want to push this image to my DockerHub registry. So in order to push this image, first of all you need to log in with your Docker ID into your Docker terminal. Most probably you are already logged in, but if you are not, you can just give this command, which is sudo docker login, and if you want to log out, then you can just write log out here, right? So let's give this command, which is sudo docker login, and then give your username here. I'm going to provide my username, and then you need to provide your password. So let me quickly provide my password and then press enter, which is going to log me in the Docker. So you can see login succeeded, and now I can just push my images to my DockerHub registry. So first thing we generally do in order to push the image to the registry is we just tag it. So we can give this command, which is docker and then tag and then the name of your image. My image name is hello. You can also take the image ID and then give the space and then give some tag to your image. So right now, because I want to push my Docker image to this DockerHub account, and which has the username code bind, I will just first of all write code bind here and then /, and then you can give the name of your image. I will just leave it as hello, and then you can give the tag of your image. So I'm going to just give the tag 1.0.0. So this tag is useful whenever you want to just, let's say, keep working on your image, and you want to update the image and want to just version your image into multiple versions, so you have the track of all these versions, right? So I'm going to just tag my image. I'm going to press enter, and then I will once again list all the images, and now you can see I have this image with this name, and I have the tag 1.0.0, right? Now once you do that, you are ready to push your image to the Docker registry. The command is very simple: sudo docker push and the name of your Docker file, which is codebind / hello. In my case, you also need to give the tag here 1.0.0, and then you can just press enter, which is going to push your image to your DockerHub registry. So just wait for some seconds, and you can see it's pushed. So I'm going to go to my DockerHub web page and then refresh this web page, and now I can see this image which is available here. And also you will be able to see that this image is a public image, so it's not private, so anybody on Docker can see your image, right? Also, when you click on this image, you will be able to see more information about the image. So here you can give the little description for your image, and also you can even write the readme for your image, what it's doing and what's the purpose of this image, right? So here is the general information about the image. You can also see this tags section, where you will be able to see the tags related to your image. I only have one tag here, and the size of this image is around 746 kilobyte, right? And also you can see how you can pull this image. So you can just pull this image using docker pull code bind / hello, and then you need to use this tag. You can just copy this and then pull this image also. Also you have the build section. This is for the automation. So if you are using GitHub or Bitbucket automation system, then you can directly push your image from the GitHub or Bitbucket into your Docker registry. You also have the collaborator tab, and then webhooks also, and then you have the settings related to your Docker image, right? So you can make it private if you want, and also you can delete your image from this section, right? So let's say I just want to pull this image. I will just copy this text, and then I will just write sudo and then paste this text which I've copied, which is docker pull and the name of my image with the tag, and it's going to pull this image if it's already not there on your operating system. So this was the simple demonstration using which you can create your images and then push your images to the DockerHub and then manage your images using the DockerHub. So I hope you've enjoyed this video, and I will see you in the next video.